Yeah, man, you can do it. And that should be us live. So thanks so much for coming along to Knots IoT tonight. There's going to be some things that we need to talk about. The first one is that we've got a code of conduct in place for tonight, and we take this quite seriously. I recognise most of the names of the people there anyway, so I know you're all nice folks. But it's important just to be nice to each other, and if you feel as though somebody's breaking this code of conduct, then the best place to get in touch is with me directly in the chat here on Zoom. Just send me a direct message, and we'll take that seriously and keep you up to date with the process there. So just be nice to each other, basically. We've got a few sponsors. Normally I know I've been saying this now, feels like for about 2 years, but essentially we'd normally be sitting in the Rebel Recruiters office eating their pizza. But being as we're not, then my company, my freelancing company there, PJG Creations, I've stuck that on there because I do the organisation for this. But Tech Nottingham, they're sponsoring us the Zoom license we're using, and JetBrains, they're sponsoring us a product from their catalogue. Tech Nottingham, in case you didn't know, they're a fantastic Midlands-based, but now global, like everybody, networking community for like-minded computer folk like us. And you can join their Slack there on the bottom of that page. And there's channels in there from anything from just general chit chat to C# to PHP to counting up in hex, if that takes your fancy. And Lee is coming back in again as well. Oh, somebody else let him in. Thank you. Onwards from that, I mentioned JetBrains, and they make developer tools for developers. So things like ReSharper, PHP Storm, WebStorm, IntelliJ, and Rider, if most people have heard of Rider these days as well. They're sponsoring us a single product for 12 months out of their catalogue there. So if you tweet on the hashtag NotsIoT tonight, then at some point after this event, I'll draw a random tweet out of a hat. Not literally, you understand. And somebody will win a 12-month license for that. So do go ahead and tweet on there. Tonight we've got, now, I should have asked you before we started, how am I pronouncing your last name, Bruno?
It's Italian, so if you sing Capuano and you put your hand like that...
Yeah, I've got to do Capuano, like that.
Capuano, that's it. Yeah, it sounds like a joke, but it's the easiest way to get to the last name.
Well, Bruno Capuano, like that, you just said. We'll be talking about TinyML and Sky Sharks, and I've been looking around this topic myself recently, and this is going to be a really interesting talk, so I'm looking forward to that. Coming up, funnily enough, Sander van der Velde, who is sitting there on my screen, at least directly beneath Bruno, will be talking about the new Things Network, bits and bobs after Christmas. This is actually the last meetup for Knots IoT for this year. It starts getting too close to Christmas, third Thursday in the month for December, so I'll let you have your December back. But yeah, Thursday the 20th of January from 6:30, we'll have Sander talking about the Things Network, so that should be cool. And actually, Cliff will be on in February talking about .NET Nano Framework as well. So keep your eyes open for those two. And another speaker, Lee Eggleston, who's sitting there on this screen as well. He'll be speaking about actually not augmented reality. It turns out it's going to be ML.NET, which is very on topic for tonight. So I probably should have fixed that before we got to that point. Apologies. But yeah, that's November the 29th at .NET Knots. So I think Jess is in the process of putting that up on Meetup, so keep your eyes out for that too. And then this coming Monday, John Lunn, Cliff Aegis, Sander van der Velde, myself, and a bunch of other clever folk are going to be talking about a whole IoT solution that we've based around a flight from London Heathrow to Budapest. Using a ton of Azure services and hooking them all together and showing how that works in the real world. So that's going to be a great event. That's at 10 a.m. GMT on Monday coming. So do go ahead and check that out. That's going to be interesting. If you want to learn then a little bit more about IoT and you want to pass the AZ220 IoT Developer Certification exam, then myself and a few other authors have created a certification learning path on Pluralsight. And if you hit that link at the top there, that'll take you to that learning path. So do go and check that out. And although we're not streaming at the moment, Cliff Aegis, Maria Anastasia Mustaka, and myself, we host a show on the Azurish Live Twitch channel talking about IoT every Tuesday night at 10 p.m. GMT. Normally, we're on a break at the moment. We're between one thing and another, but mainly, as Cliff pointed out, we just didn't want to take any viewers away from .NET Conf because they need every person they can get, really, and we didn't want to steal all their viewers. So we've been paused for a little bit, and then moving on, there's the Azure-ish Live channel itself, and in fact, John Lunn over there, he's got a show on it. Which is fantastic as well. It's worth catching up on. And when the new year comes, the actual Azure-ish Live show will be back at 12:30 GMT or BST, depending on where you are. So keep your eyes open in the new year for that. And myself and a few other folk create an Agile Engineering podcast. So if Agile Engineering, DevOps, and that sort of stuff is your bag, then do go and check that out as well. And with that, I will stop self-promoting and showing my screen, and we can get Bruno speaking. So let me just stop sharing. We'll take questions in the chat. So if you just make sure you're muted, Bruno will do his presentations, and I'll just interrupt Bruno at convenient points to ask the questions, and then we'll do the open mic questions at the end and go from there. So thank you very much, Bruno.
Yeah, sure. So let me share my screen. And we can start. So, other window, there it is. Stop the camera and so can you see my screen?
Yep, all good.
Perfect. So, hey, hello everyone. Thank you very much. Again, it's a pleasure to be here. And also, I read a lot of stuff. I watch a lot of stuff that all of the people here are doing. So I'm happy to try to show something else back because I learn a lot here. And again, my topic is going to be something different. Sorry about that. It's not the standard presentation. It's basically talking about the stuff that we can do. That's myself. I lead innovation in Avanade, Canada. I've been an MVP for several years, and I like to start, let me hide myself, with kind of a disclosure about, sorry about the crappy animations and the crappy demos. This is what I usually do, and please do not use any of these codes in production. I mean, you may want to use it. I'm going to share everything at the end of the session, but it's mostly for fun. And what I am going to talk today, it's about sharks and why sharks, and you are going to see. So I always like to do this intro where I talk about Jaws. Jaws is probably the most popular terror horror movie around sharks that we've seen. It's from the 70s, so it's kind of old. It's been in the top of most amazing movies for several years. But then at some moment, someone realized that in order to make an even better movie about sharks, you need to make sharks flying. So why not to make them flying in a tornado? And then you have Sharknado. Sharknado is, if you like these movies, if you like this is not for everyone, but if you like these movies, hey, this is great. This is kind of a very fun way to spend your Saturday evening or whatever. And you have 6 movies of this, and this is kind of, let's add an extra layer on top of standard those movies. And then a lot of people start to think about what else we can do. What is the next level after Sharknado? And by the way, I think Sharknado 1 is 2013 or 2012. It's probably almost 10 years ago. But then 2 or 3 years ago, someone said, okay, let's do something else. Let's pick up sharks and let's flying sharks and let's add some rockets to them. Let's make them zombies or whatever. There is a movie which is called Sky Sharks. It's super crazy. And hey, you can even see that this was happening in the machine learning world. Machine learning is a super old piece of part of the computer science. There is a full story to tell here. We don't have time. I'm not going to go there, but we've been doing machine learning for almost 50 or 60 years. There was kind of a winter in machine learning, in AI, that everything was stopped, but we've been doing this. And because I am not going to show today code, I am going to show code at the end. I planning to do my intro. I planning to share with you how do I get here. couple of years ago, we moved to a new house here in Canada. We get a new cat. This is Goku the cat. And Goku the cat likes to go outside and bring some friends. So he goes outside and gets some mice, gets some little birds, or even a squirrel or whatever, and he brings them here. So my wife kindly asked me, if I have so many devices at home, can we do something to see if Goku is entering the house with a mouse or whatever? And I said, yes, computer vision is here to do this. But when you start to do computer vision, everything seems to be simple because, hey, let's try to figure out in slides if this is a cat or a dog. And this is kind of the ABC of computer vision. But when you start to learn, when you start to figure out what is there, how you can do this, things are starting to become tricky. For us, this is a dog, this is a Chihuahua. So this is kind of easy to do. So we see a photo and we understand Chihuahua. If we think about the computer world, what we are going to see, and we are going to see a lot of this later, they are all numbers. A picture is an array of numbers. And if you have a color picture, a VGR picture example, each pixel, each position in the photo will have 3 values for each one of the colors. So it's not as easy as seeing this. When you start to learn image recognition or computer vision procedures, what you learn is that you need to do deep learning. Deep learning are kind of step-by-step small machine learning procedures, and you start to apply some algorithms, some filters to the image until you get to this classification, a dog or a cat. So probably the first thing that we are going to do here is make this grayscale, then try to get some sharp the contour, and get the nose, I'm sorry, the eyes. We can do a lot of things to get here how we can identify Chihuahua at the end of the day, and this is a very old joke. We are going to have a routine that's going to identify Chihuahuas and muffins. It's super, super tricky to do this when we start to code. So that's why when you start to enter here, you see that there are kind of 2 ways to do this. And by the way, this is probably the most slide that I'm going to show, then I'm going to be all demos. We have 2 parts of the equation here, which is we can use out-of-the-box models like Azure Community Services with everything that we have in Vision, or we can use platforms. We can create our custom modules using TensorFlow, using PyTorch, machine learning.net, and we are going to have a session in the near future about this. We miss something in the middle, something like this, something that is flexible enough to do this. And lucky for us, there is a product to do this. And the product is basically going the ABC of machine learning. Machine learning, I'm sorry if there are some experts in the room, but machine learning ABC is we pick up some data, we prepare our data. If we are working with, I don't know, with data, we start to label and tag this data. Then we choose an algorithm. We train a new model using this algorithm with the data that we prepare in step number 1, and then we have a model that we can use. And a model is, most of the time, is kind of a black box. It's a function with an input and an output. In the Azure world, we have custom vision, and we have a lot of people who already know how this works, but this does the ABC of machine learning, which is basically, we are going to prepare our data, which is upload images. That's fine. We are going to upload this, and it's going to be the one that we are going to tag. Then when we have our visual data set, we are going to train a model to identify this, and then we can use that model. And I'm going to go fast until that last part, because when we train the model and we get there is where we start to have tons of options to see how we can deploy these models to the cloud, to a local machine, to a device, or to a very tiny device. So that was slides. Let's start for the beginning. And again, you already know this, so I am going to go fast in the first part. So custom vision.ai. Everybody can try this. Everybody can use this. You only need an Azure license, or you can try this for free. And when you create a project, there are several ways to create a project. Let's do IoT drawings. Oh, let's go for a better one. Let's go for sharks. So there are several ways that we can do this, and we can do classification or object detection. In object detection, we need to tag in the images the object that we want. Classification is kind of, this is a house, this is a car, this is a cat, this is a dog. And we can also have one label per image or several labels. I am going to have this very, very simple, and I am going to have a classification model with a single tag. But this is the part, this is the section that is kind of important. We can choose specific domains. When we are using custom vision, we are basically use a technique which is called transfer learning. We are going to use models that are already trained to do image detection. And on top of that, we're going to use our own set of images, our own set of information to basically train the model to detect what we want. And there are models who are already trained and they are working very, very great to identify food or landmarks or retails. And there are models who are already trained also to be exported, the compact section, the one that we see in the bottom here. This is the one that we are going to use. And these are maybe not as powerful as the general ones, but these models will allow us the chance to be exported and use it later with a few tweaks in very small devices. So I will go here for general, here, and export capabilities, the standard ones that we have, and create the project. Couple of seconds later, I will start to do the next step, the first step of machine learning, which is oh, where is my project? There it is, shucks. Let's add images here. Super simple. I have already, I have a data set, which is the most boring data set ever, but I have this. Let me go to the edging pose. I have these drawings, and why do I want to use these drawings? Because they are easy and they are fast to train. This is just black and white images, white background and the drawing in black, so it's super easy. I start to upload my images, I start to do my tagging, so these are fish. Then I will add a couple more for flowers. By the way, you can do this or do this, all of this using scripting. You don't need to do this in the wizard mode. I like the wizard mode for this small test. And I have humans. And as you can see here, when I need to add a tag, I have the option here to use the two ones that I already created, fish and flower, or negative ones. I can start to add images that doesn't make sense to have also a data set of stuff that I don't need. So I upload my images. I have 24 images. I think still 8, the minimum number of images that you need to use here. All is here. What I can do right now, I start to train my model. I am using the cheapest version from this. Also, I select quick training. This will take probably 30 seconds up to 10, 15 minutes to train the model. But the idea is that once the model is trained, I can start to use it. So because I don't know how much it's going to take, let me pick up another model, same set that I already have. And I already trained the image, I already trained the model. When the model is trained, I have this precision, recall, and IP numbers that basically give me an understanding of how is my model working. And at this moment, I can start to test my model. So I can go open one of the most amazing tools that Microsoft have, which is Microsoft Paint. And let me go here. And this is my skills of drawing. Sorry about that. And let's add an IoT in the bottom. So let's save this. Sorry about the crappy fishy IoT. I will save this in my desktop, and then I can upload this file. Go to the desktop. This is my new image. It's going to try to understand the image, and of course, this is super simple. It's created not to fail. It's detected like a fish. I have 95.3 probability that this is a fish. So this is fine. This is the stuff that we can do. And I like about custom vision, and you're going to see more and more on this, is that you don't need to code here. You don't need to do anything. You just can basically use the visual wizard to train the model. And once you train the model, you can start to use it. There are several ways to use this. We can publish the model here. We can, once we publish the model, we are going to have a URL that I can post, make a post to this URL, and I'm going to have a JSON file a JSON response that is going to basically give me information around I detect a fish here or detect something else. But this is what I really like. We can export these models. And there are different ways that we can use the trained model. Remember, we train a model to identify crappy drawings. Remember, crappy demos is my stuff. And what we have here is the chance, in example, I can export this for TensorFlow, standard. Everybody in the machine learning world, TensorFlow is kind of the standard. We can use Onyx. We can export the model as the Onyx. Onyx is a standard. It's kind of an organization where we have a platform like NVIDIA, Microsoft, Amazon, Facebook, a lot of big players are there, and they created this standard to define how a model is going to be used. And it's super cool because you can export the model as Onyx and use in Linux, Windows, Mac, several platforms. So it's kind of nice to have here. And we also have the chance to export this as a Docker file. And when we export this as a Docker file, what we are going to have is the TensorFlow mode to detect images that we created, and we have the chance to export and use this trained model to detect images in Linux, Windows, or even small devices like the Raspberry Pi, so we can do this. So if I choose here the export for Linux, an example, and I export the model, what I am going to have, I am going to have something like this. Download, take some time. I am going to have something like this. So let me go here. Let's go to Docker. I already download this and install this locally in my file, locally in my machine. And I am going to have an image. This is a standard image. As you can see here, is going to be a Python image for Linux using Python 3.7. Then it's going to start a couple of dependencies here. Most important is probably TensorFlow to do all of the machine learning and to do all of the computer vision stuff. Then we are going to use also Flask. Flask is a web server that is the one that is going to basically create an app so we can do the image analysis. And that's basically it. After that, it's going to open a port. I change it to use the 8658. And then we have an app here, and the app is a super simple app. Please let me know if the font is fine or we have some more. I need a bigger font, but we have an app here, a Windows. A web app, and it's basically going to create the app and create two endpoints where we can show and call this web app. In one of the endpoints, we are going to post an image there on the right of the image, and the other is going to post basically the URL of an image, and it's going to download the image, and then it's going to do the analysis. And in order to do the analysis, we have here another Python file, which is the predict.py file, and then it's going to load the model. This is the model, the PV, this is the big file, this is everything that we did visually that is trained is here. And when we train this, we have the three labels, and we have here a manifest to see how we are going to use. But the idea here is that, go away, once the model is initialized and we know how to use it, I am going to get an image. I am going to, the web application is going to receive an image, it's going to analyze the image, and it's going to give us the result. So if I go back here, let's minimize something. I have here this model running in my Docker desktop. So let's open Docker. It should be here soon. There it is. So I have here my CV drawings running. This is the logs. Sorry about that. You can't change the color. But if I open, I don't know. If I open Postman and make a local call to this service, I am going to do the image recognition analysis, not in the cloud, not in the custom vision.ai. Background is going to be running all local in my Docker container. So here I am using Docker. I am using Docker just to avoid me. Yes, I don't want my history. Oh, I deleted the history. So let's create a new one. So I think this is it for. Let me figure out my IP. 191, so and the port that this is open, it should here is, let's go to Docker, it's open in 8058, so I need to call my local 1.7 8058/image, and the only thing that I need to do is in the body, I need to add a binary file, and I'm going to select from the desktop the fish IoT, and I'm going to make a call. When I make a call, you see that it's image. No, it's not image. Let me take a look at the endpoint. It should be, yes, it's not image. Okay, it doesn't like the.
Does it need to be post instead of get?
Oh, yes. Sorry about that.
It's okay.
Somehow I lost my history, and it should be open here.
Pair programming at its best. Love it.
There it is. So, hey, thank you very much. And this is the output. This is the crappy, fishy analyzer, and we see here that there are 95% of chances that this is a shark. When I trained this before, I used shark instead of fishy. Sorry about that. And very low chances that we have a human or a flower. We can even test this. Let me do my crappy version of a flower with the mouse.
I want to see what it does when you do a Maui from Moana with a human with a shark head.
I mean, it's going to be. I am not going to be able to draw that, but if I do something like this with the eyes, big mouth, and I do my foot and hands or something like this, let's say this as shark human. So I have my shark human. And the cool thing about this, and what I think is really important, is that almost the same, because it's the same model but running in different platform, almost the same model. When I do the flower here, I have 64% the flower, which is good. If I do the flower in my local Docker container, let's go here, select the flower, post. I have here, oh, it's a shark. It should not be a shark, it should be a flower. So it's almost the same, and let's give it a try to the human to see what we have here. Shark human.
That's interesting, isn't it? Because is that the exact same model?
It's not the same model. When we select the compact version, it's a specific one running to do this. And hey, it's a shark. It's here. It's always a shark.
So yeah, you've got the compact one deployed down onto your Docker container, but you're using the general one essentially in the web version there.
Yes, and that's kind of the idea. And by the way, this is, if we really need to do this, we need to use much more data here. It's not just the 10 images. We need to use much more. Somehow this one is a fish.
Yeah, I think if you've got the head of a fish, you're a fish, you know.
the way that, yes, the way that it's analyzed is starting to from top left to right, to start to read like this and started to create the pattern to analyze. But what I really like is that, hey, once you have it here, once you have it exported and running here, and again, this is just to show that we can run this locally, we can run here. It's super easy to do this, to export this for a Raspberry Pi and use it in the device, use it in the Raspberry Pi. So it's literally the same model, it's literally the same stuff that we have, but with different, let me export this and show you the difference. It's going to use some different libraries because we can't use the full Linux image here. We have image libraries, we need to use smaller ones, but we can run this in a small device. And we will have the chance to have a small Docker container running in the Raspberry Pi. So let me go back
This
here.
is a Pi 3. This is a Pi 3 you're running it on as well.
Yes, this is a Pi 3, and I am uploading this, I am unzipping this, and just to show you the code, this is what we have in the Pi. Where is my code? Oh, it's opening. So is the same? Yes, I trust my computer. So it's the same Docker file, but it's using here, I get the Docker file, yes, it's using here the slim version of Python, and it's installing much more stuff here because you need to do tons of stuff here in order to use it. So it's kind of a heavier one, but it's the same idea. Here in the app, we are going to see that we have the same application, the Python application, and then we have the predictor application with the same model. Everything is already here, but we can run this in a small device. We can install Docker in a Raspberry Pi, and we can start to run this in the Raspberry Pi. So it's literally the same context, the same idea. The main difference is that there are some different packages that need to be installed to be running the Raspberry Pi. What I did is that because it's already packaged and it's already there, let me close this one and close this one, is I created an Azure IoT module that's basically image drawing, there it is, where's my module here? I created a module, an Azure IoT Edge module, that's basically runs this inside the module. So once you see here that first step is initialize the module, I do the Azure IoT part, basically register this as a module, then start to read data if I have in my listeners, or enable the C2D. It's not going to do anything, just basically recognize images. And then I create the custom vision app, and here I have the two endpoints. The main difference here is that once I recognize an image, I do the prediction of this is a human, a shark, or something else. I'm going to also send an IoT message. And that's it. The only tricky part is at the end that because you need to run this at the same times, you need to run this in different threads. So you have IoT here and custom vision here. You can sync all of these using a loop from async.io. But this is a standard Azure IoT Edge module. And then what I have here is another Raspberry Pi up and running with, let me go here to my, no, not this one, here. I have a set of devices. I have one IoT Edge device. I already have and registered one IoT Edge device with my Raspberry Pi running, and I have one of the modules in the device here in the modules. One of the modules is the image drawing, and this is the module that I just created. This is the module that I published, and I did everything here. I have basically some information here, like when I create the module, I open the module in the port 8089, and then I have a variable here to see, hey, when you get a value, when you analyze an image, report this. It's very simple code. I want to share everything here. But the idea is that this is now the same model that I created in customvision.ai with a couple of extra lines of code. It's an Azure IoT module, and I can go to my ARP IoT door 2. I can go to
Sandra had a quick question there while you're typing. saying that when you create the Docker image, you get that Python code for free, including the endpoint. And if you deploy it to the container and the endpoint's directly available, you kind of answered that a second ago where you had to map the ports. I mean, I know, Sandy, you know about mapping IoT edge ports, but you're really talking about the Python code and the endpoint, aren't you, in that respect?
Yes. So you have kind of everything for free. Yes. And you have the endpoint, but you can create your own endpoints. You can tweak this and whatever version you have. This is my Raspberry Pi, this is the module that are running right now. So you have the same stuff that we see on the cloud. We have the image drawing here. If I go to the IoT Edge logs, image drawings, I will have this. And if I enable this in tail mode, so there it is. I can go back to Postman, pick up the same image, start with fish, and oh, I will use this one. Lesson learned is post, thanks about this. Go to the body, go to the, I think I am running out of battery in my mouse. Select file, send this, and this is sending this to the Azure IoT. There it is. This is what it's doing. It's resizing the image, doing some cropping, and I have the results here. ID, project, iteration, everything that we have, that we need here, and in Postman. Where is Postman? There it is. Have the same values.
Sander had a follow-up there as well. What are the extra lines added to that IoT Edge module? What's the purpose of that? Which extra lines were those, Sander? I missed that.
Yes. So let me go back to here. What I did is I create a module, an Azure IoT module in code. And when you create a module, it gives you kind of a template with a couple of lines to register the module. And once you register the module, you can start to add logic here. So what I did is basically add here in the module, and I write about this. I'm going to share the links later. Add the line. So once the module is registered, the module is going to enable and get up a web application doing the image recognition. And every time that you post, because it's a web endpoint, you post an image, it's going to analyze the image and it's going to trigger the message as a result to the Azure IoT Hub, running in the Raspberry Pi. So this is not running in my machine. This is running in a very small Raspberry Pi that I have somewhere here. I think I have the camera here. So this is the one somewhere here in the back of this. There is a small Raspberry Pi. Back there, this Raspberry Pi, and that one is running the image recognition. I mean, it's not doing anything right now. It's just running the web server. But what I like about this is that, hey, once you have this and you publish this module to an Azure registry container, so it's a Docker image that you can handle, you can store in your container, you can go here, you can go to your module tree, and you can start to, you can add here, and you can have your module, and you can start to say, you know what, I'm going to add this module to be run here in this ARM, and I'm going to say, okay, this is going to be a new module, name, image, sharks. I can't remember the URI, but this is the place that you are going to get this Docker image, and then you can add some environments or whatever. It's going to be full managed, but as your IoT. And as I mentioned, I write about this. How to create an Azure IoT module from an Azure custom vision. Yes, there it is. So I'm going to share this one here. I wrote a couple of posts basically defining the step-by-steps of what you need to do, and make the project, make the Azure IoT, do everything here. I show all of the steps. I show the file that I added, I remove it. I like to write this because I'm going to forget this tomorrow, so I write this for myself. And this is the final step. And I think I also probably share the code somewhere here. I will share the links of the code if you want to take a look. It's not complicated, but it's nice to see that we can start here. We can create our own image recognition module, and then we can move everything to the Azure IoT Edge device in a very simple way. And by the way, this is also sending telemetry. If I start here, the Explorer, start Explorer, go to my hub, my devices. This is my device. And go to my modules. Somewhere here is the image drawing module. There it is. I can go and start to see the telemetry. So I can start this. If I send another image, let's send the scary human, the shark human, to these IPs, the Azure IoTs, is the Raspberry Pi. So this is going to do the analysis. As soon as it finishes, I have here that again is a shark. I don't know why, but at any moment there it is. This info, this is all in Azure IoT. I don't know. Hook up this to a live streaming, to a real stream analytics or whatever. The info is here. Save this in a database. Hey, once we are in Azure IoT, it's super easy to start to see what else we can do and how we can work with this. So, how I am on time. Oh, fine. So this was kind of the second part. This was, hey, we are in IoT. We can use amazing devices like this one. We can do more stuff. I am not going to go over IoT. You know all of this stuff. I don't want to do this. But then we have the third part, which is basically how we want to, what happens if we want to go smaller? What happens if we want to go to this $4, $3 device? What are the options here? It's not as easy as use a wizard. So this is where tiny machine learning, tiny ML comes to life. This is where you need to, for me, it was basically go back to learn, to study, to test, to the stuff that we've seen are easy. I quote easy. They are not easy, but this is the one that we can do stuff, and mostly because we have these MCUs all around us, and they are cheap. And then, yes, Pete have one right there. So they are everywhere. And one of the most easy entry points here is TensorFlow Lite. TensorFlow Lite, it's kind of nice. Everybody has a small one. TensorFlow Easy is kind of a nice one because one of the ways that we can use TensorFlow Lite is we train a model, we can pick up a model that's already trained, and TensorFlow Lite is going to transform the model in a small model. And basically, you are not going to have a model anymore. We are going to have a list of C classes, C code that we are going to use in those devices, which is kind of nice. And then we need to figure out how to run these classes in this device. And then we need to understand how the device is working. We need to understand which are the limitations of the device. We need to understand if we are going to use an 8-by array or a 16 or whatever, because all of the devices are different. And there is a full set of tutorials that I'm going to share with you, because if you're going to go here, you probably need to spend a couple of hours understanding how this works to see what are the headers that you need to do. Once you have your data and you transform your data, how you're going to use it. It's not complicated. It's easy. You can do easy things here, but it's super, super, super tricky in the sense that if you are going to use one of these small devices, tiny devices, you need to tweak your code a lot. So then you need to have one version to use the Arduino, which is super cool. Very small. This is small like a thumb. It's super small. It's low battery consumption. Then you have the popular ones, Nano, Arduino Nano, and Raspberry Pi Pico. Not Zero, Pico. This is the RTOS. Again, yes, it's there. So it's not the standard Raspberry Pi. It's a different. It doesn't. We don't need to sync on operating system here. We don't have Linux here. This is real time. There it is. Yes, you have it. And what I like also to play around a lot, because it has a lot of sensors out of the box and you can do most of the stuff, the Wii terminal, yes. This is a $40 device, maybe 50 or maybe 35, I can't remember. But it's an Arduino-based device, and out of the box has a lot of cool features. So you have a Bluetooth and Wi-Fi for connectivity. You have an accelerometer for movement. You can read, you have a screen. It's a 320 times 240 resolution screen, I think. You have also the chance to use SD card to store information. So there are plenty of stuff that you can do. And you have a couple of buttons. You have two. That's the battery, Sander. There is a module because in the back, I don't know if you can see here, but in the back you have the pins there that basically you can hook up on top of the pins of the Raspberry Pi and do it. And it's also a battery that Sander is showing. I'm going to try to find an image that you can plug in the back, and you have a 4 hours running all the time battery here, which is super cool. And hey, I like this device. For prototyping, for testing, I like this device. Also, as a plus, you have in the bottom a couple of Groove connectors. If you are in the Groove world from Arduino, this is, you can connect a lot of sensors here, a lot of actors, a lot of stuff that it's easy. You are going to avoid soldering and cabling and wiring and whatever. It's here. So what I like about, yes.
A quick question there, this is a really good question actually. What is actually lost when you use TinyML rather than the previous, and it quite rightly says big stuff for the Raspberry Pi?
You lost accuracy for sure. And of course, and you're right about this, and of course, speed. I mean, you are not running this in a powerful CPU or in a powerful processor. You are running this in a much smaller one. And you are going to do this, but you are going to win battery life. You are going to win, if you can run this in a very small device, this device can be up and running days with the small battery. The Raspberry Pi with the same battery is going to be a couple of hours or something like this. So it's the balance of what you can and can't do. The best example of this that I always tell is that if you have an Android phone or you have an iPhone and you have your wake up world, hey Google, Siri, or Alexa, sorry if I am waking up devices in your house. This stuff, yes, this stuff, when you say the wake up world, even if you have a very powerful phone, I have a kind of a powerful phone, I like my phone, with a big CPU and GPU, the wake up recognition is not working on the GPU or the CPU of the phone. Because if they work like this, they're probably going to kill the battery in a couple of hours. They have a very specific chip trained to recognize, hey Google, Siri, or Alexa, that once it's recognized the voice and running in a very low power consumption mode, is going to wake up the system. But it's not running in the main CPU because it doesn't make sense. It's going to be much more power consumption there. So, hey, if you can optimize your model, and that's super tricky, you need to do a lot of stuff, and you can run this in these small devices, that's a win-win for everyone. You are going to have the chance to do a lot of stuff. So yes, speed and accuracy, it's great. And I see that Clifford said he won one via Benjamin. Oh, Benjamin, he did an amazing, I have it somewhere here. I don't have it enabled here, but he did an amazing, I'm going to get there, how we can do this. How are in time? Fine.
You've got plenty, you've got all night, Bruno. You know, don't rush on our behalf. People will leave if they want, but most people are just going to stick around. So the hour I was talking about is really just for a quick break in case anyone needs a wee. You carry on talking. This is awesome.
Yes, no, the main idea here is that, as I mentioned, we can do coding here, and I'm going to do some coding here later. But there is a platform, and a couple of you already know this platform, which basically allows us to do the same stuff that we've seen, which is Edge Impulse. It's a very visual tool. Oh, I am not logging in Edge. That we can create ABC wizard projects to do machine learning, and we do different scenarios, not just images. We have other scenarios on the cloud, and it's super easy. So, an example, if I want to do an image recognition module, let's create one for Sharks CD05. And then we are going to see that it's basically the ABC that we know. So what we want to do, here we can do accelerometer data, audio, images. This is an image project. What we want to do, very similar like before, we have image classification or object detection. The second one is that we need to basically select and write our objects in a big picture one by one. Let's go for the first one, the one that we already use. And there are several ways that I can get information. So I can connect to a real device running Azure IoT Edge. I can import my data if I already have it, or I have there is another way to do this, but it's more command line, that we can also do this kind of a bulk mode from command line, but the two first are great. I already have my images here, so I'm going to upload my images the same way that we already seen. So let's go for my disk, machine learning. Let's go for fish, all of my fishes, and I will label this fish, upload the 8 files. Let's do the same for flowers. As you can see, so far is the same concept. Let's upload data and let's upload the humans. Typo, human. We can upload, there it is. Once I have my data uploaded, I will see here that it automatically, based on the amount of items that I upload, did the splits. I have 80-20 almost to train and to test. I have my images here. I can take a look and see what they have. So the next step is to start to work with the inputs. Basically here, this is the part that we don't have. This is the option that we don't have in custom-vision.ai that we have here. I will start to add blocks here. I will say, okay, I am going to work with images. So I will use and normalize the image. That's it. I don't have any more options. And I will add a learning block. So I am going to do transfer learning. Remember that we talked that custom vision is doing this, but we don't see it. Now we see here what is going to happen in the back. So I'm going to do transfer learning, and that's it. That's my impures. That's the impures. Once I have this saved, what I need to do, I can start to make some tweaks. And I like this step because this is something that we don't have in custom vision. And if we know what we are doing, and when I am going to do another demo, you are going to see more details here, that will give me the chance to basically scale, to basically generate features, identify features, and even go deep on how we want to do this. How many training epochs that we want to do, which is the quality that I expect at the end, and yada, yada, yada. This will take a lot, not a lot, it's take a couple of minutes. I will use models that I already have created, but I want to show you here, once it's finished, that I can do the same stuff here. I can do plenty of things, and I can even do the transfer learning. And when I do here the training, this is the model that starts to do, hey, I have everything uploaded and tagged. Let's start to train, but I can define how many cycles I want to do this, how the learning rate. The learning rate is a number that we use to basically make our model much more accurate. It's much more complicated than that, but I don't want to go deep on that one. But hey, we can do all of these things here. And again, I forget about this. This is free. This is a service that you can use for free right now. When we finish training the model, there is also a new step that we can tweak the model once it's trained. It's going to take some time to a specific platform. So I can go here to the Ion Turner. I can configure the target. I'm going to say I'm going to run a vision category for my. Let me take a look at this. Oh, sorry, I lost the combo. This is all the options that we have to choose. We have standard Arduino things. We have the wheel. Where is the wheel? The wheel terminal here. We can tweak this to be used in a MacBook, or hey, there are plenty of different platforms that we can, devices that we can choose here. And if I go here and say, okay, train this for the wheel terminal, and I start this, it's going to tweak all of the settings that I want to use at the end with the model to be used in the wheel. Let me open in the wheel terminal. Let me open one that I already created because it's going to take a lot to change. So go here. So sharp mix. So let's go to this one. This is a model that I already trained. So I have the Ion Turner complete here. You can see there are plenty of analysis that is doing based on the images and the type of train that I want to do. Focus on the wheel terminal. So I have a lot of stuff here. I can train, retrain, I can test my model. So let's test the model, the one that I have. So let's go to data acquisition. Let's upload my crappy fish that I have here, the label fish. It's there. And if I go to the data acquisition, I will say my fishy IoT here. Let me move this to the test set. So I can go here and go to the live classification. And if I choose fishy IoT in the model I already trained using the same images here, after a couple of seconds, I will get that this is probably going to be uncertain. It's not a fish. This is happening today a lot, not expected output. But I can understand here that I have 30% chances to be a fish, 31 of a flower, and 39 of a human. So somehow it didn't fit on any of these. Super weird. It should be a fish. And I can start to use also here to go deep and to see what else we can do. But the important part, what I like about this, and again, remember, my data training set is not very good. It's basically very, very bad. That's why I have this bad output. But at any moment, I can go here to deploy, and I can deploy my model with specific target or specific device. So I can go, for example, just the plain library. I am going to figure out how to export this model and use it in C++. Or I can export this for Arduino or for a specific set of firmware. I have the Nano here or the Sony's presence here. And if I go for Arduino and I download this, what I am going to have is a zip file that is going to be good enough. It's already there, that I can open later my Arduino IDE, import this zip file, and I'm going to be access to start to work with this. And let me show you how this works. There it is. So I can go here. Let's create a new one. I don't care about this one. And let's go for sketch. Let's go to include the library add zip. And if I go to my download folder, I will see the shard here. Once it's uploaded, I can go here to file, examples, and at the bottom, I will have Shark, static buffer. This is a sample created of the model that I trained on the cloud to analyze images and yada, 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 but ready to be used in an Arduino device. And the most important part here is that in order to do this analysis, what I can do is I need to figure out how to get an image. So we are not going to run, we can run a web server here and we can get this. I need to finalize a post that we have about this. And I can go here to the browser, go to the model testing, pick up my image. Sorry, to live classification, pick up my image, and then have from here the full feature row, basically pick up the image and convert the image to the right of byte that we need, go back here and paste. Yes, I need to save here. Sorry about it. Let me save this here on video terminal 04. I can save it here and then I can upload this to my machine. I have already connected one. I already have connected a video terminal here. It's going to be on, let me see which port. COM8, so I can compile and upload this to my video terminal, and it's going to pick up all of this buffer of data, which is the representation of my crappy image, and it's going to do the analysis, which is the problem. And you are going to see this in a couple of seconds. The image is not going to fit. I have very, very low memory here. I have there are ways that we can make it work. There is a way that we can do, but the ABC is not going to work. So in order to make something, and we can do images, but I should probably write a little more about this and then show you the final stuff all running here. So in order to do this, what I decided to do is, okay, this is going to take a while. This is going to fail at the end. This is going to do a lot of stuff. But remember that we have other options here, that we have the chance to create new projects. I can create a project using audio. I can say IoT Sharks, microphone, mic 10. I can create a new project. There it is. And when I have my project, I can start to say, this is going to be an audio project. I can pick up audio from my device, but I already have data from my audio. So let's start to add my audio files. And my audio files are here. So the same way that I have images, I have audio files here, and what I have some several categories. Let me upload all of these, which are other words. There it is. Let's add the second one, which is background. A few for background only. And I have the sharks. Several for sharks. So once I upload all my files, it will do the same process here. Sorry, it will basically create this. I have this amount of sharks, then background, there are other words, the same with the split. I have already 80, almost 8713, which is not good. I probably have more data to split, but I can start to create my impulse here. And it's going to be very similar to what we just see, but because we are working with audio here, we have the chance to do a couple of other stuff. So I will say, you know what? My audio chunks are 2 seconds. Let's add the processing block here, which is going to be the MFCC for audio. Then add the learning block, which is going to be classification, because we want to classify this is going to be a shark, or I don't care about other words. And once I have this, I can save the impulse. I'm going to start to do the next step. The next step is going to analyze the audio. This is where I'm going to start to see the raw data. And I am sharing. How do I share with audio? Share sound. Let me know if you can hear this.
Hey Shark.
Perfect. So this is a lot of hey shark, hey shark, hey shark. My background noises are probably going to be very boring. Just clicks. And let me see, in other words, you may have some Spanish. I'm speaking here.
Forgot.
Yes, something is speaking there.
Only
changes, so a lot of stuff. But here we have some parameters that we can do the configuration. This is stuff that we were talking before we started recording about the difference between doing a model to do image analysis and audio. This is the, okay, how you are going to do this. Even if we have features, even if we have kind of a simple diagram with the audio, there are a couple of things that we can do some custom parameter here. I'm going to do this by default, don't want to change anything. Again, I already have this trained. It should be faster than the visual one, but it's already trained. And after it generates the features, we are going to have a model that we can use in our device. So let's wait a couple of seconds. In the meantime, I'm going to go back here. It's still compiling. It takes some time. still compiling for do the image recognition for the device. Yeah. And this one, let me close this one. I will close the empty one, and I go back here, and it's already generated the features. I have everything ready to process, so I can start to do the training. And the training cycles number, how much time I want to spend here, the learning rate, again, stuff, and start training. It will take some time. I am not going to do this. I already have one of these done, but let me show you a couple of things of this. If I go to the Sharks Mixo 3, this is the one that I already have trained. The Ion Turner is already done, it's already applied, it's focused on the Wio terminal, so it's here up and running. The live classification module, it's kind of working fine. If I go, I'm sorry, if I go to model testing, I have this analysis where you can see that one other word was well classified as other word, the other not. Sharks usually works fine. Background, not very good. So there is still some room from improvement here in the model. Remember, this is all very easy, very just to show what we can do. But again, at any moment, I can go back here, select Arduino, download my model, and I can use it. I already have one of these users, and I want to show you how this works. So
Dan had a quick question before you do that. How generic can the data be in Edge Impulse? Can it be arrays of numbers, for instance? Images and sounds are cool, but normally simple sensors will just output floats or integers.
Yes, so I will show you how I did it, because I use another tool from Edge Impulse, which is a visual tool, and I recorded for using that, because I use the same mic as the Wio terminal have to do the recording. That was my idea. And hey, if you have a better mic, if you have better quality, I don't know. I will probably suggest that audio and images are kind of tricky because it's dependent on the sensor that you use, the camera or the microphone. If you have accelerometer, if you have more simple data, accelerometer is just a vector, 3 values, it's going to be, you don't have any problem there. It is what it is. With the audio, I would probably suggest, okay, try to use clean audio to train for a specific label, and also use a background one to basically also define that, hey, this is background noise, or this is other word. You need to train for what you want, and you need to train also for what you don't want. But you can't cover anything that you don't want. So it's super tricky. The data part is usually where we spend most of the time in the machine learning world. This is the fun part. This is the amazing one. But the data is the one that keeps us a lot of time. And this is just finished. This is the one for the image. And I just want to show you that the main problem that we have here with this is that my head is there, so you are not going to read it. Sorry. Let me scroll back here. That the text is not going to fit. The text, the full image that we have there, byte by byte, is not going to fit into the flash from there. So we need to, it's not just resizing the image, we need to do a couple of techniques there to make it work. Again, I am writing about this, I am not there yet. I need to finish the writing to show how we can do this in the Wio terminal. But if we go to do the mics are kind of easier, and I can open the mic project, and what I have here is a similar project with a mic trained model to detect words. And what we have is we are basically using the Sharks microphone model to do the inferencing. And let me add this one here so you can take a look on this one. And once I enable and start this, every couple of seconds, is going to pick up the mic voices, is going to analyze this, and it's going to show in the serial windows how it's working. So
Dan asks, can you store the data in external memory? Actually, to take that forward, I suppose you could store it on an SD card, but how slow would it be? I wonder.
I haven't, that's a good question. I will not sync of this in a very fast device to write and read data from the SD. I will probably use this. I will show you later how I create one. And this is spoiler that when you say shark, is going to show the name of a shark. I hope so. But I haven't think of how fast that will be.
Reading is not too bad. And I mean, the ESP32 CAM device that we mentioned before, it's got a built-in SD card reader on it. So I guess, I mean, you wouldn't need to write anything to it. That's the slow part of SD cards normally, isn't it? Reading, for what you're doing, I mean, so long as you're not analyzing video, if all you're doing is capturing a still every 5 seconds, probably work quite well.
Yes. If you avoid that, it's going to be, I probably use the SD to, an example, if I'm using the accelerometer or something like this to write there the data, but I don't know if I need to want to read and write. I probably need to test more. Again, this is a great device for prototyping. And if you want to try that scenario, I will suggest, okay, use this one because you already have the SD reader here, you have an accelerometer, you have plenty of stuff here, which is kind of working. So right now, in example, this is the one analyzing and recognizing voices. As you can see, it's mostly background noise here. 89 background, 90% background, 88, because it's what's happening in the back. And if I start to say, hey shark, 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 I should probably, let me put this one here, closer. I should start to get values around, hey shark, come on shark, do something. Hey shark, it's not doing anything. We clear the output and start again. Hey shark, I don't get any shark. Hey shark, oh my God, not one. Shark.
You're gonna have to do it with an English accent.
Shark. Hey, this was running before, but I want to show you the latest one, 5 more minutes with the latest demo. So this is all amazing, but when you have the Wheel terminal, you want to do this stuff in a visual way. So I write a lot about how you can basically connect the Wheel terminal and to Azure IoT and connect your, let me show you. How you can use your Wheel terminal doing something like this, where you have the Wheel terminal and you press a button and it will open the door. The door is connected to Azure IoT, and you can see the Wheel terminal here with the screen. You want to use the screen to show data. It's refreshing the data. It's doing almost everything there. By the way, this is available here. But the Edge Impulse team also have a very cool tool, which is called CodeCraft, which is a visual way. It's basically kind of a Scratch. If you know Scratch from the MIT, it's a block-based solution that you can do and you can create you can use to create your own solution for Wheel terminal. So in example, when you do a Wheel terminal project, if you choose what you want to do, use the accelerometer, use an external sensor, use the audio, and then if you are going to do audio, let me create one from scratch. And let's say, let's create a new project for Wheel terminal. So when you create a new project for Wheel terminal, it's going to ask you, what do you want to do? You want to use the motion recognition, you want to use the gesture recognition, the wake up words, the small recognition, everything here. So if you go for a wake up and do a name, IoT, my Bluetooth is not working fine. My keyboard is not working. Come on, React. Okay, so I don't have a keyboard. Let's wait a second. And once you have everything here and you start to train your model, what you can do is use this directly to pick up, I have my labels here, sharks, background, other words. Use this. This is a very simple model. That you can see here that the first step is if I press the button A, I am going to do a sample for the microphones to basically pick up label audio for the label shark or for background or for other words. I can upload this to my device. So let me upload this. Let's start to close some stuff here just in case. And let's pause. So I need to install an agent here, but I don't need to basically do anything of coding here. I will upload this and it's going to install a new app on my Wheel terminal. And from here, I can so that's the Wheel terminal. If I press a button here, hey shark, I will get a new value here for shark. This is the one that I just saved. If I press the C button, it is. These are other words. What is happening here? It's using the microphone from the Wheel terminal. It's sampling the data in the Wheel terminal, and it's upload this directly here to my project here in the cloud. So I have here other words. So I can use the Wheel terminal to train with my wake up words, to use 2 seconds, 5 seconds, 10 seconds wake up words. And when I have this, after I train my model, I can start to also do the programming of the model. So let me open the one that I already have created. I go here, do not save. Is the other one, sorry. There it is. So this is my program. What is going to happen here? So let's see if I can. Oh, my keyboard is dead. Oh, there it is. So what is going to happen here? I define block by blocks what I want to do in the Wheel terminal. Let me minimize this so you can take a look. So I will start in the setup, and you can see here we have setup and loop, because at the end this is all Arduino code. I am going to do in the setup, define the orientation of my Wheel terminal, the background color, the text, the color, and I will define here a variable to define the confidence, 70%. Then I will going to do in the loop, I am going to start to get information from the microphone. And I am going to show at the specific locations, I am going to show the current values of the predictions for sharks and for the other values. So I have here sharks, I have humans, I have the background noise, and I need to change this for other words. And once I have this, let's change this for other words. Once I have this, I will check if I press the button A, or if the button A is pressed and the confidence of the word shark is bigger than the confidence that we define here in the top, 70%, I am going to show the shark image. So it's a very simple one. It's a very simple project. And let me show you this up and running. Another Wheel terminal here with this up and running. And let me show you the Wheel terminal. So what is going to happen now is showing in real time the word that is the recognizing. So you can see there, let me zoom this a little. So you can see there that shark is 4%, 3%. Human is, I don't know why human is so high. Background noise is 12, 10, 13, 14. And then we have other with all of this. When I press the button and I say shark, it should show the image of the shark. So if I press the A button, shark, it detects a human. This is what's happened in demo, in demo mode. Remember, my data are very bad. So I will run again. Shark, hey shark, shark, hey shark, hey shark, and a human again. So maybe I mislabeled the data. Maybe let me run this one last time.
Yeah, it was pretty confident you were a human, wasn't it?
Yes, this is what's happening in demo mode, that you have these things. I should probably change delete the shark one and put it. But what I like is that, hey, we can use this and almost with zero code, have the chance to start to build something. And by the way, there are a couple of modules to do Azure IoT stuff here. So we can we can define the Wi-Fi password, of course. Then we can do the Azure IoT Central, connection, values, scope, primary key, and device ID, and then start to publish data to there. As you can see, as you can probably guess here, this all came from Benjamin works from the smart nose. So you have the multi-channel gas sensor. But this is another way that we can do stuff in a very, very easy way, and I like it. I mean, it's fun. It's fun to have a different way to do this. And at any moment, and this is the last step, we can go here, take a look at the code, and start to understand, okay, how this is working, what are they doing, in order to see what we have. Because in example, when we export this code here to use audio, it's use the standard PDH, I think, or PDM, I can't remember the name, the Arduino library to use audio, but with the video terminal, we need to do different stuff. So hey, you can copy here, these lines here, and the microphone lines there to make it work. And that's basically it. Let me give this a final shot. I will get here. Shark. Oh my God, there you have a shark. The only demo that is working today. No, my God, keep it there. Okay, but this recording, I will probably edit all of the video and show only this. Just to finish, and that's it. I will share the code, everything is here in my GitHub. As I said at the beginning, this is for inspiration only. Do not use this in production. It's up to everyone. But here in the bottom, yes, not to come IoT. You have the Azure IoT solution. You have the custom vision for TinyML, and also you have the Docker images that if you want to use. I will share the slides later. It's kind of a big review of a lot of stuff here. I prepared a last slide with a review of what we've seen, but it's so many things that we've seen today: custom vision plus computer vision, plus on Windows, Raspberry Pi, on tiny devices. So there are so many things. But hey, I am happy to learn, to see the other sessions, to see how we can move forward, because we talked about this before we start with Pete and the people. A couple of years ago, this was impossible. Today, we can do these kind of things, and I really, really like it. And I am looking forward to see what else we can do in the next couple of months or next year, because it's becoming easier. And we have platforms like Edge Impulse that are doing a lot of work for us. And even with custom vision, we can get to a Raspberry Pi with almost no code. Raspberry Pi and Azure IoT with almost zero code, which is a super powerful platform. So that's it. Going back to you, Pete, unless we have more questions.
That was really cool. Yeah, thank you so much. That was excellent. So yeah, really enjoyed that. Yeah, I mean, feel free to come off mute if you've got questions. Sander said just ship it. After you got that shark to work, just ship it. It was done. I think
I need to do a special thanks to Sander, because a couple of weeks ago, I was struggling to do some Azure IoT stuff here in the ESP32. And I think I found a blog post from you for a couple of years ago when you talk about JSON and doing post and really doing HTTP client GET using the ESP32. And hey, you opened my mind that the problem for me was that I was using a newer version of a library that didn't work with the latest version, so I need to roll back a couple of versions. And again, I was struggling a lot to see why it's not working until I realized that it's not the code, it's the version. My problem was that the version was It's not that there was some incompatibilities there, and your blog post was the one that basically opened. Oh my God, that's probably the solution.
Thank you. And now I know why I got a like on something from 2 or 3 years ago.
Sander,
Yes.
your blog is a go-to. Basically, I'm constantly telling people how good your blog is. I need to go and check yours out now, though, Bruno, because you scrolling down that list, it was like, oh, geez, there's loads of cool stuff on there.
Extra homework.
Yeah,
You
definitely.
ruined my weekend.
You've not got time on the weekend. You've got to be prepping for Monday, Sander. I don't want you slacking off.
I will put the Monday session, your session on the second monitor. It seems like going to be a lot of cool info there. And hey, I want to have this there and take a look. And it's nice that you're doing this on Monday, because as you just say, it's probably not going to ruin my weekend. I will have 5 days of where I can play around with things. If you do that on a Friday, it's a different story.
Yeah, that's true. No, it's going to be good. I'm quite looking forward to that. We want to, when this session's done, we want to add a bunch of AI to it. We've just not had time, but we definitely want to add some AI to this whole thing, because I think there's some quite cool stuff that we could do to make this, to take all the data that we generate while we're doing this, and then plug some AI in the other side as well. So it'd be interesting to see what we can do with that. Different story for AI, really, rather than what you're talking about here, of course. But yeah, be interesting to see what we can do with that. Yeah, so if you've got any questions, then come off mute and ask them at this point. Don't rush at once. We've had quite a lot of questions as we've been going, to be honest. I think you've made at least 3 of us buy WIO terminals as well. I know Cliff and Sandra both already got one, but Alan and I have co-opted each other, and we've joined forces to get free shipping from DigiKey to get that 2 WIO terminals delivered. And then it's not long after John said he was going to buy one, and sadly too late for the order. I wish I could probably cancel it, but God knows what will happen if I try and do that.
Yeah, thanks Bruno for that extra expense. Appreciated.
So sorry about that. But no, but again, this is a super cool for prototyping, for learning. It's a super cool device because it has what you avoid wiring, you avoid a lot of stuff, and you can, probably not go to production, or maybe yes, but for learning and for testing, this is great. I have several here. As you see, not all the demo works. This is what's happened. Sorry about that. But you learn a lot. I really, really learn a lot. And then when you move to the ESP32 or other scenarios, it's easy to connect the dots. And I like it. And also, you have a screen, which I love a screen. I am too tired to do system, print line, or whatever. You have a screen. You can show info there. And I love that. I love to have a feedback of what is happening in the screen.
Yeah, I want to try some of this. Cliff mentioned before he left about using .NET Nano framework, and it'd be really interesting to see if there was a way that we could combine the two. But my thought is, though, that using something like .NET Nano framework is going to use so much of the available space on something like an ESP32 that you're really going to limit yourself in the model size that you can use. So I think that might not work personally, but.
Yes, I didn't even go there. I need to go back to do stuff with .NET in small devices. I used to do Gadgeteer and microframework a long time ago, but I never. Somehow I always go back to do some C++ coding and go to the root. But I would love to find a cool solution using .NET because hey, it's .NET. Mm-hmm. It's amazing.
Yep, .NET everywhere.
Bruno, do you have some ideas or plans to add a camera to the WIO terminal?
So I was talking with the Seed Studio people to see what they think, because yes, you have a Groove connectors here. So I was talking what they think about connecting a camera, if they have a good camera. They have a Groove camera, which is very bad. But again, this is Arduino, so it's not bad. It's what you can expect on these devices. So yes, I was hoping to do this. The closest thing that I did was when I did the thermoscan, whatever, that was very popular last year when COVID started and everybody wants to try to do thermal scanning. I created this also using Raspberry Pi, later the Wii terminal, but not right now for me. What I want to do, and this is kind of self-promotion, it's basically using the door. Let me enable the door here. This door is an IoT crappy door. This is connected to the cloud. It's basically a digital twin of the door. And I have here a couple of flavors to use the door. And one of the flavors is because I have a virtual use of the door. I created a 3D world. Oh, there it is. Let's leave it there. I created a 3D version of the world that I can use and connect. And if everything is up and running, that should be up and running. Let me see if I need to start the web app. Once I connect this and I move this, oh my God, my keyboard is not working. Let me get another keyboard. This is my backup keyboard, which is a Raspberry Pi keyboard. So here, what you see once it starts to move, there it is. I start to move my player around and get close to the door. The physical door open, the virtual door go open soon. There are some seconds delay here. Yes, I know. The door needs to open like this. My physical door opens up and down. And if I get out here, you will see that the door will close and then the physical door close and the virtual door also close. All of this is Azure IoT. All of this is digital twin in the back. And I was struggling to figure out, I am using this right now to get a nice and decent wake up word for open door and closed door in the Wii terminal using the microphone to open this. And I want to use the camera for something else. I don't know, maybe have the Wii terminal here nearby with the camera. And when you get close with a small real Lego figurine, open the door. It's a learning process, but the camera is probably in the bottom of my priorities right now. And I'm sorry to plug this in.
Mm-hmm. Love it. By the way, I forgot to mention, and before people leave, it's the Tech Nottingham Christmas party on the 6th of December. And Knots IoT, myself, on behalf of Knots IoT, and also .NET Knots with Jess, we're going to run a little quiz isn't the right way to put it, but they're having the Christmas party, and then you can win prizes, and there'll be competitions for each of the meetups that take part. And Knots IoT and .NET Knots actually are running two little pieces of that. So Knots IoT have just retweeted the link to their Christmas party information, and I think we're going to get some Microsoft swag to give away as prizes in those competitions. So by all means, and it's a global thing, so you know, if you're in Canada, for instance, and you can come along, I think Microsoft are going to post this stuff out, so I'm guessing it should be fine, but most of the people are going to be from the UK, let's be honest. But yeah, so going to be fun. I think for the .NET Knots one, we're likely to be doing what did we say we're going to be doing for that? I can't remember. Pictionary, I think, game essentially. And for the Knots IoT, we're going to be doing a jigsaw, but it's not going to be any regular jigsaw. You'll see that on the day. So kind of a treasure hunt jigsaw. So yeah, come along, win some Microsoft swag.
Is it an in-person event?
No, online.
Okay.
Yeah. So yeah.
And free.
Not free. I think you have to pay. But
Yeah, I was trying to look at the registration stuff. I thought I saw something saying it was free, but
I think you've got to pay. Although, you know, to be fair, I've not looked.
last year you had to pay because they had some commercial entertainers, we call them, who
Yes.
did games and stuff.
That's right. You might find it is free, you know, this year. It doesn't mention paying on there at all, does it? So the tickets tend to go really fast because that's how they do it. But there's other teams as well. There's top prizes, I think, from something else as well. So it's not just our meetups that are going to do it. There's 4 or 5 different meetups that are involved, and Tech Nottingham themselves. So I meant to put this at the start of the meetup, and I completely forgot because of reasons. But yeah, it's there to be had. So do feel free to come along to that. That'll be good as well. Apologies, Bruno, I caught you in the middle of what you were doing, but I didn't want to forget, and I didn't want people to leave before they heard about it either.
No, that's fine. And I stopped sharing the screen. So if you want to share the link or something.
Oh yeah, yes, I can do that. Hold on. So just stick this down on the screen. That's a really good point. Let me move. Oh, my PC's going. What, you want to do more than one thing? Hold on. There we go. Let's share this. So this is the party. The tech party here. So the link will be in the chat shortly, wherever the chat is. There it is. Everyone, there we go. Oh yeah, so it will be free. That's not the link. That's just a 0. Don't follow that link. It won't take you anywhere. There you go. So that link will take you there. So yeah, you can read all about it there. And then there was the tweet that. Copy the link to the tweet, and I put that on the screen here. It's always fun. The Tech Nottingham community is awesome. So if you've never been to one of their events before, it's worthwhile coming along to that. Oh yeah, look, it says free right in the tweet. So yeah, all you need to do is register when the tickets are released, and yeah, and you can see Knots IoT I mentioned. Actually, that should read .NET Knots. I don't know why they keep saying DDD East Midlands. I've got nothing to do with it, but .NET Knots have. And Jess and I are doing the .NET Knots one, and I'm doing the Knots IoT one. And yeah, it'll be, yeah, I'm not going to give away too many spoilers about what I'm doing for those. So yeah, do come along and join in on that. It'll be quite good fun. To go back to Bruno's stuff, you're going to post a set of links, aren't you, to your code, GitHub, blog, slides, all of those good things.
Yes, let me share the links for the. This is where you can find the code, and I am loading the slides to SlideShare right now.
Brilliant. Yeah, share the links on Twitter as well, and I'll retweet them from Knots IoT, and people can get them from there as well if they've already left. With that, I'm going to stop streaming on YouTube at this point. So thanks to everyone on YouTube, and we'll see you in the new year for Sander van der Velde talking about the Things Network. So stay